Hello. We are starting right triangle trigonometry. Gonna get tricky with it. So, this is a great video that the school, WSHS, have done great videos. And there's another one that I will send you to help you remember SOHCAHTOA. So SOHCAHTOA is just a way to remember the ratios for a right triangle that we can do. So the basic trig functions are sine, cosine, and tangent. So sometimes instead of writing it like this, we'll write it like this, because what it means is sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. Now, what does that all mean? Well, if you look at a right triangle, and what's important to know about trigonometry is that it can only be used in right triangles. So that's why we call this one right triangle trigonometry. There's other trig stuff that we can do, and we'll talk about some of it at the end of this unit, but the stuff, any SOHCAHTOA can only be used in a right triangle, just like Pythagorean theorem can only be used in a right triangle. So if we have triangle A, B, C, if you have angle C we're looking at, and you can look at any of the angles except the right angle. You can never find the sine, cosine, or tangent of that right angle. So if we're looking at angle C, the adjacent side, adjacent means next to. So if you were to trace angle C, then, my computer jammed up a little, there we go. So this is angle C. One side of angle C is your hypotenuse. The other side, that's going to be your adjacent side. So it's next to angle C. It's one of the sides. And the side that it doesn't include as one of its two sides, that's going to be the opposite side. And it's always across from that angle. So that's how you find your opposite, adjacent, and hypotenuse side. So if we were doing another one over here, and we called this A, B, C, and this time we looked at angle A, then if I trace angle A, again, one side is your hypotenuse, and this other side would be the adjacent side. So next to angle A, part of angle A, and then across from it would be your opposite side. Okay, so let's do a couple of examples. For triangle CAT, evaluate the three trig functions of angle theta in simplest radical form. So we want to find, let's start with sine theta. So for finding sine theta, that's going to be opposite side over hypotenuse. So all these they're just ratios of the sides. So you could write them as fractions, you can write them as decimals, and then theta, which is just a variable used for angles, or here I used A on the top. That's the actual angle, and we can use it to find the angles as well, which we'll talk about in a couple minutes. So before I can do this, I am going to circle theta and say, okay, well, I know that the side across from it, that's going to be my opposite side. So I'm going to label that with an O. And the side next to it, if I trace that angle theta, one of those two sides is my hypotenuse, which is always across from the right angle. The other side is my adjacent side. So I'm looking for O and H for sine. So sine theta would be the opposite, which is 5 over, oh wait, I don't know the hypotenuse yet. I need to find it. How can I find the missing side of a right triangle? Oh, you said Pythagorean theorem? Then you would be right. So Pythagorean theorem, I'm just going to do down here. So 5 squared plus 10 squared equals, and this is actually side C squared. So then we have 25 and 100 gives us 125. Take the square root. We want to leave that in simplest radical form. So C, or side AT, is going to be rad 25 times rad 5, or just 5 rad 5. So my sine theta will be 5 over 5 rad 5. And I want to simplify that. So my two 5's can cancel out, leaving me with 1 over rad 5. I can't leave a radical in the denominator, so I multiply the top and the bottom by rad 5. Leave me with rad 5 over rad 5 times rad 5. You might be thinking that's radical 25. And what's the square root of 25? Is 5. And what I'd like for you guys to be doing, though, as soon as you're multiplying a radical by itself, instead of in your head going to rad 25 and then 5 next, start to think anytime I multiply a radical by itself, it gives me what's underneath that radical. So rad 5 times rad 5 would be 5. Next, let's do cosine theta. So cosine theta, so ka TOA, is adjacent over hypotenuse. So we're still looking at theta. This time we want the adjacent side. That's over here. A is 10 over hypotenuse is 5 rad 5. We can reduce 5 goes into 10 twice, leaving us with 2 over rad 5. We can't leave a radical in the denominator, so we multiply the top and the bottom by rad 5. 2 times rad 5 is 2 rad 5, and rad 5 times rad 5 again is 5. And then lastly, we want to find the tangent of theta, which is our TOA, opposite over adjacent. So I take the opposite side, which is 5, adjacent side, which is 10. So tan theta is equal to 1/2. So those are your 3 trig functions. That's cosine, and that one's sine. And they're just in simplest form. So the next part says solving for a missing side of a right triangle. So anytime I'm looking for a missing side in a right triangle, I have 2 options. I might be thinking Pythagorean theorem, but in order to use Pythagorean theorem, I need to know 2 out of the 3 sides. And if you look in question number 2, I only know 1 out of the 3 sides. So I can't use Pythagorean theorem. So my other option is to use ka TOA. And the more you write this out on your papers, the more you're going to remember it. And make sure you spell it correctly. It's so, O-H, and then ka, C-A-H, TOA. So the directions say circle the given angle. So we circle 70. But to be honest with you guys, you could have found this other angle here to be 30 degrees. 20 degrees rather, sorry. And then you could have used the 20 degrees. We don't want to because you may add wrong, or it could just cause, one little mistake would cause other mistakes later on. So I always like to use the given one, but you cannot use the right angle here. You can use either of these acute angles. So I circle that, and I'm going to label the sides that I know and the side that I'm looking for. So this side over here is my hypotenuse because it's across from the right angle. And this one is across from 70, so that's going to be my opposite side. So now I have an O and an H. So I look up here and I say, which of these has an O and an H? Well, sine does, our SOHCAHTOA. So does. So we want the sine. We're going to use the sine function. There we go. So we always do sine of the angle, cosine of an angle, tangent of an angle. So my angle I'm talking about here is 70 degrees. So I'm going to do sine of 70 degrees equals opposite over hypotenuse. My opposite side is x, over hypotenuse is 12. I'm going to put it over 1, and then we're going to cross multiply. So we get 12 sine 70 equals x times 1. Now also, when you write this 12 sine of 70 over here, please make sure the 12 is in front of the sine. Do not write sine 70 12. That would not be acceptable. You have to write as 12 sine 70. Couple things that you want to make sure here. Make sure you are in degree mode in your calculator. So once you reset your calculator, it automatically goes into radian mode. So from now on, when we reset our calculators and we're taking a test or quiz or the Regents exam, then there we go. you want to make sure you go to mode, and then you're going to come down here where it says degree and hit enter. Okay, and then you can do second mode to get out of that. Now that I'm in my calculator, I'm going to type in what I had, which was 12 times the sine of 70. If you don't change it to degree mode, though, you will get the wrong answer because it will be in radians. And then you're going to write out that entire decimal on your paper. So 11x, approximately 11.2763145. And this doesn't say to round, so we're actually just going to leave it just like that. All right, let's do number 3. So first thing I'm going to do is circle my given angle. So I'm given 50 degrees. Again, I could find my acute angle, but I don't need to. So I find the 50 degrees. I label what I know and what I'm looking for. So I'm looking for the hypotenuse, and I know the adjacent side. So I look over here, which one has an A and an H? Well, CA does, which means I'm going to use cosine. We always do cosine of the angle, sine of the angle, tangent of the angle. I wrote it on itself too much. It's a little slow today. So I take cosine of 50 degrees, cosine of the angle, equals adjacent, which is 6, over hypotenuse, which is x. Put it over 1 and cross multiply. So again, you're going to put the x in front of the cosine. Do not, I repeat, do not write cosine 50x. It has to be x cosine 50. The x comes first. Now this one's a little bit different because we need to solve for x. So we need to get rid of this cosine of 50. Since they're being multiplied, we're just going to divide both sides by cosine of 50. And you're going to go to your calculator. And what I would recommend doing here is I would probably do my alpha y equals, make it a fraction, and then do 6 over cosine of 50. And then hit enter. Always good to be using that alpha y equals key. And then you're going to write that whole decimal out on your paper. It doesn't say to round, so you're going to just leave it as is. So that right there is how to find a missing side. Next, we're going to talk about solving for a missing angle. So to solve for a missing angle, it's a very similar process. The biggest difference here is we're not going to cross multiply whenever we're looking for the angle. Instead, we're going to use one of these trig functions, the inverse trig functions. We're going to start the same way. Step 1, circle the angle you are looking for. So before we circled the angle we were given, now it's the one we're looking for. So I called it x. So I'm asking you to find that. So after I do that, I'm going to label the given sides with an O, an A, and an H. Across from this side is my A, and across from that side is my opposite side. Next to this angle, so one of the two sides that's not the hypotenuse is my adjacent side. I'm going to write out SOHCAHTOA. And the more you write it, the more you'll remember. And I am looking for which one has an O and an A, because those are the two sides that I know. I know one's 3 and I know one's 4. So I'm going to use tangent. Now, if you knew all 3 sides, you could use either sine, cosine, or tangent. They all will give you the same answer if you use the opposite, adjacent, or hypotenuse, whatever it calls for. So tangent of x equals opposite over adjacent. So here's where it is very different in that we're not going to cross multiply. I want you to train your brain to think anytime I'm looking for an angle, I'm going to use inverse trig function. So inverse sine, inverse cosine, or inverse tangent. And those inverse just means that -1. The -1 does not mean the reciprocal. If you remember learning about negative exponents, it's very different than that. It is an inverse function. The -1 is just the symbol we use to represent it. So we're going to take inverse tan of 3/4, and that will give us x. It's kind of like taking the inverse tan of both sides, and that's what gets rid of the tan on the left side. So go back to my calculator here, and I'm going to do second tan. That's how you find those inverse trig functions. And they're in blue above each of my trig keys. And inverse tan of, I think it was 3/4. Let me just double check. Yeah. Inverse tan of 3/4. And actually, again, it's a good idea for you guys to be in the habit of using your alpha y equals keys. So 3/4. Enter. And that's our angle. Now, you're going to write that whole thing down, but then we're going to talk about something else we're going to do with this. I asked you to find the measure of each angle x to the nearest minute. So right now, this is all in degrees right here. So this number right here is degrees. I want it in degrees, minutes, and seconds, which is just a different way of representing our angle. It's used a lot in like navigation, different applications, different ways of writing it, instead of having a long decimal. So to do it, all you're going to do is you're going to go to Second Apps, which is your angle menu, and you're going to go down to choice number 4, which is DMS. That stands for degrees, minutes, seconds. And you're going to hit enter. And it gives you the answer in degrees. This symbol is degrees. This little apostrophe is minutes. And the little quotation symbol means seconds. So those two are equivalent to each other. So we're going to write that out on our paper. So we got x equals 36.869. And then that equals 36 degrees, 52 minutes, and 11.632 seconds. So it says to the nearest minute. So how do we round this? Well, I want you to think about time. How many seconds are there in a minute? Well, there's 60 seconds in 1 minute. And then there would be 60 minutes in 1 degree. So when we're rounding, instead of using our 0.5 and up, we're going to use 30 or more. So if it's 30 seconds or more, you're going to round up to the next minute. If it's 30 minutes or more, then you're going to round up to the next degree. If I asked you to round to the nearest second here, then you would just use your normal rounding rules. So it would be 36 degrees, 52 minutes, 11.6 seconds. But since I said to the nearest minute, we're looking at how many seconds we have. And since it's less than 30 seconds, it's going to stay at 52 minutes. So it would be 36 degrees, 52 minutes. If it had been over 30 seconds, we would have rounded up to 53 minutes. And also very important that you write how many degrees, because the minutes is just, it's a smaller unit than a degree. So we have to include how many actual degrees there are first. All right, let's do the next one. I'd like it if you could pause the video now and give letter B a try on your own. All right, so first, hopefully you circled your angle and then said this side across from here is my opposite. And I've got the hypotenuse given to me as well. So I'm going to do O and H, that's sine. So I would do sine of x equals rad 3 over 3. Since I'm looking for an angle, I want to use inverse trig functions. So inverse sine is going to give me x. Do not cross multiply. Now I go to my calculator and type in inverse sine of rad 3 over 3. So second sine and alpha y equals, want to do rad 3 over 3. And you would write out that whole decimal. And then while I'm here, Second Apps DMS. And here, if you'll notice, we have 51.803 seconds. So for this one, we're going to round up to the next minute. So our final answer here, and you should have those other ones written out as well. To save time, I'm not going to, but you should have 35 degrees, 16 minutes for your final answer. Okay, so that covers how to find a missing side and how to find a missing angle. So we're going to kind of put that all together now, and we're going to try to solve a right triangle. And if I ask you to solve a right triangle, I want you to find all the 3 missing sides and also the 3 missing angles, so 6 pieces of information. One thing to remember here, 2 things. If you're given capital letters, then you're talking about the angles. So capital A, B, capital C. If you're talking about lowercase letters, it's the sides. And we name those lowercase letters based off of the angle across from it. So notice here, lowercase c is across from angle C. Lowercase b is across from angle B. And lowercase a is across from capital A. Always draw a picture. Always use the entire decimal to find the values, and round as your very, very last step if it says to round. That's the last thing you want to do. You do not want to use rounded values to find other answers. And there's going to be more than one way to set these up. So this is a solved triangle ABC. I'm going to draw a picture with right angle C. So it doesn't matter where I put A and B then. Capital B, so that must be an angle, is 24 degrees. Lowercase a, so that's going to be across from side A, is 8. Round your final answers to the nearest 10th. So first thing I might do is I might say, okay, well, let's find angle A. I know all the angles in a triangle add to 180, so I'm going to subtract the 90, which gives me 90, and then subtract 24, which will give me 66. So the measure of angle A is 66 degrees. So good news, I'm done with all the angles. I know all 3. Now I need to find the missing sides, and I have one of those. I need to change that setting on the vacuum. So I have the 3 angles, and I need to find the 2 other missing sides. So it doesn't matter which one you find first, and it doesn't matter which angle you use to get it as long as you don't use the right angle. I like to use the angle that I've been given just in case I made an arithmetic mistake. I don't have all wrong answers after that as well. So I am going to use the 24, and I have to use the 8 because that's the only side I know, which is my adjacent side. And I need to find one of the other sides. So let's do side B first. So that's going to be my opposite side. So this is my lowercase b. So to do that, since I have an O and an A, if you write out your SOHCAHTOA again, I want to use tangent. So tangent O is of the angle, sine of the angle, cosine angle, tangent of the angle. So tangent of 24 degrees equals opposite, which is lowercase b, over adjacent, which is 8. So this time I'm not looking for an angle, so I can put it over 1 and cross multiply. So I get 8 times tan 24 equals b times 1 is b. Then type that right into your calculator, and it should give you about 3.56. So it does say round your answers to the nearest 10th. So we'll do 3.6 for that one. And then lastly, now we need to find the other side, which would be side C. Again, I like to use the information I know for sure was given to me. I prefer not to use decimals if I can avoid it. So I'm going to use the 24 because that was given to me. I'm going to use the 8 still, so still have an adjacent side. And this time I'm going to find the hypotenuse. So now I look over here and I say, well, which one has an A and an H? And that's this one, cosine. So I'm going to set up cosine of the angle. So that's cosine of 24 equals adjacent 8 over hypotenuse, which is lowercase c this time. Again, not looking for an angle, put it over 1 cross multiply. I have c times cosine 24 equals 8 times 1 is 8. Divide both sides by cosine of 24. Type that right into your calculator. You can use your alpha y equals again. You get 8.75709, which is approximately 8.8 to the nearest 10th. All right. And last couple questions are using sine, cosine, tangent to answer questions. So the only new part that you might not be as familiar with here is the vocab for angle of elevation and angle of depression. So think about angle of elevation as kind of your lookup angle. If you're standing down here, you have to look up to see the top of the tree. Over here, if you're standing at the top of the lighthouse or in the top of the lighthouse, you need to look down to see that boat. The beauty here is that the angle of elevation is always equal to the angle of depression. Why? Well, here you have your horizontal line of sight for angle of depression would be parallel to the ground here. So what we've created are alternate interior angles. So if those lines are parallel, then those angles are congruent. And here again, if I was finding my angle of depression, it again would form those alt exterior angles. So the angle of depression is always on the outside of the triangle. Angle of elevation is always inside. If you're struggling with this concept, just always put it in that bottom little angle of your triangle as your angle of elevation, since they are the same. Usually angle of depression is harder for students to figure out. All right, number 6, we've got a 27-foot long wire stretches from the top of a vertical pole. So here's our vertical pole to a stake in the ground 21 feet from the foot of the pole. So we've got a stake in the ground over here, and that is 21 feet from the foot of the pole. So if this is our pole, here's the foot of it on the floor. And we have a wire that goes from the top of that vertical pole all the way to that stake in the ground. And that is a 27-foot long wire. The hardest part with these is really drawing your picture and figuring out what they're asking. So find to the nearest minute the measure of the acute angle that the wire, so this is the wire, makes with the ground. Let's call that theta. So now I say, okay, well, the vertical pole makes a right angle. So now I have a right triangle, and I know 2 out of my 3 sides, but I'm looking for my angle. So that's when I want to think to use SOHCAHTOA. So I circle my angle and label my sides. I've got hypotenuse and adjacent. That tells me I'm going to use cosine. So cosine of theta, cosine of the angle, is adjacent over hypotenuse. Whenever I'm looking for an angle, I want to use my inverse trig functions. Type that into my calculator. Write out my decimal. And let me show you again. Go to your calculator, clear this out. I'm going to do second cosine 21 over 27 and second apps DMS, hit enter. And this said to the nearest minute, I believe. So, yep, nearest minute. So we're going to say, okay, well, we have more than 30 seconds. So we're going to round up. So this would be 38 degrees, 57 minutes. 38 degrees, 57 minutes. That's to the nearest minute. Okay, so I would say try and pause this. See if you can at least draw the picture on your own would be important, because that's always difficult. All right, so we've got a 108-foot high building. So here's our building, right? I'm a really great artist, as you can tell. So we know the building is 108 feet high. An observer measures the angle of depression of a bicycle on the sidewalk as 29 degrees, 40 minutes. So there's somebody standing at the top of this building, and they're measuring their angle of depression to a bicycle. So your bicycle Oh, I don't think I can draw a bicycle. And a seat. I don't know. You're got your horizontal line of sight from this person, and then they're looking down at 29 degrees, 40 minutes. So here's our right triangle. So this angle right here is the same as your angle of elevation. So if you couldn't draw this, at least make sure you put this angle at that bottom angle for the angle of elevation. Buildings sit at right angles. At least we assume they do. And then we're going to set this up here, circle my angle, and I know the opposite side, and I'm looking to find the distance from the bicycle to the base of the building. So we'll call that X, and that's going to be adjacent. So I've got my SOHCAHTOA written out in the last one. Always good to write it multiple times. I'm going to use tangent here. So tangent of 29 degrees, 40 minutes equals opposite 108 over X. So this one I'm given the angle, so I can cross multiply. Again, write your X first. So X times tan 29 degrees, 40 minutes equals 108. Solve for X by dividing by tan of 29 degrees, 40 minutes. And then we did not talk about how to type in that 40 minutes yet. So go to your calculator, and we're going to do alpha y equals 108 over tangent of, I think it's 29 degrees, 40 minutes. So 29, you're going to type in, then you're going to go to second apps, again, that angle menu, and you're going to hit the enter for degree. Then you're going to type in the 40, again, go back to second apps, and you're going to hit 2 for minutes and close it up. So DMS, the degree symbol, and the minute symbol all in that same menu. And 108 divided by that. And then I would like this as a decimal here. So I can hit math, des. And the older calculators would probably give it to you as a decimal. And our final answer is 189.600. And it said to the nearest foot. So 189.600, you would write that out. And then we would round that to 190 feet. All right, that's it. We got Triggy. Let me know if you have any questions, and I will post the homework for this as well. Have a good day.